All right, today we're going to be solving trigonometric equations. So right here, we're going to look at problem number 2. We're going to work it out in our journal. Right now, when you're solving trigonometric equations, I want you guys, if it says x, I want you to understand this basically means theta, which represents the measure of an angle. Okay, that's what theta represents. Today we are going to work in radians mode. We're going to be working in radians mode. We might switch back to degree mode to help you guys understand. You can go back and forth, but we're going to have all of our answers in terms of radians. Okay? Right now we're going to be solving for x, so I'm just going to rewrite the equation. I have 2 times the sine squared of x minus 1 equals 0. Now, we're trying to isolate this variable known as x. What would you guys think would be the very first logical step to get this right here, this expression, by itself? What would you do? Add 1. I like it. I'm going to add 1 to this side, add 1 to this side. So we have 2 times sine squared of x equals the number 1. Okay. What do you think if you had to put money on it? What would be the next logical step that you feel pretty confident would be the accurate step?
Divide by 2.
Divide by 2. I love it. We're getting closer and closer and closer to solving for x because 2 is being multiplied, so I'm allowed to divide this side by 2. I'm allowed to divide this side by 2. So these 2's will cancel to a 1. And now we have sine squared of x equals 1/2. Now let me explain to you what sine squared of x means. This might give you a clue. Sine squared of x means the sine of x times the sine of x. So if I don't want the sine of x times the sine of x, and I just want just the sine of x, and that's it. What do you think, Fred?
Would you plot the inverse of sine?
Not yet, not yet. Because that'd only take care of 1. You still have to, right now, what you would want to do. By the way, if I said x squared equals 1/2, what would you guys do to solve for x squared equals? Take the square root. So that's what we're going to do. Just like we would take the square root of this side and take the square root of this side, we're going to take the square root of both sides. Now, when you take the square root of the sine of x times the sine of x, all you're left with is the sine of x. This is where it gets a little confusing sometimes. Just so you guys know, whenever you have an equation, like x squared equals 25, and you were to take the square root of both sides, technically your answer would be x equals plus or minus a 5, because negative 5 times negative 5 is 25, and 5 times 5 is 25. So over here, make sure you please put plus or minus the square root of 1/2. So it's not just the square root of 1/2, it's plus or minus the square root of 1/2. Now what we're going to do is we're going to focus on this side. Before we apply the inverse, Raymond, we're going to simplify this side. Practicing radicals. Right now, this radical, don't worry about the plus or minus, just know that our answers will have a plus and a minus in it. I want you guys to rewrite it as the square root of 1 over the square root of 2. So anytime you have a fraction inside of a radical, for example, if I say the square root of a over b, that equals the square root of a over the square root of b. These are equivalent as far as their value. But are we able to take the square root of 1? Sure, it is a 1. Are we able to take the square root of 2? No, we're not able to, are we? But we're not allowed to have irrational numbers in the denominator, so we have to multiply both the numerator and the denominator by a radical 2. And you get radical 2 over 2. So everybody, this is what your simplified version of a square root of 1/2 becomes. So we started here, and what did we finally end up with? We ended up with the simplified version. So we have sine of x, which remember x just simply means theta, equals plus or minus radical Now, if you wanted to figure out what x was, all right, you could. If you didn't, some of you already know what theta is. Okay, some of you may not. Watch what happens if you are in. I'm going to change my mode to degree mode because it'll probably make sense to you if I do it this way. I'm going to hit second sign, and I'm going to type in radical 2 over 2. Like that. Hey, look what angle I get. What is that? 45 degrees. Okay. Now, if we were in degree mode, we would say x is equal to plus or minus 45 degrees. Well, that doesn't make a whole lot of sense when you're dealing with the unit circle, okay? But right now, I'm just going to put x equals 45 degrees. What I want you guys to do in your journal right now is we're going to draw a unit circle. Here we go. Here's my unit circle. Here, here. Now, we're going to look at all the places that you can make a 45-degree angle. Right here is a 45-degree angle. Right here is going to be a 45-degree angle with the x-axis. Right here is a 45-degree angle. And right here, I feel like I don't see the 45-degree angle. Job of drawing here. Do one long line. Try to split that perfectly. That's a little better. Okay. So in these right triangles right here, you are at 45 degrees right here. This angle right here is 45 degrees, this is 45 degrees, and this is 45 degrees. Okay? In the unit circle, okay, whenever you're at plus or minus radical 2 over 2, you are at 45 degrees right here. You are at 135 degrees right here. You are at, let's see here, that's 180. 225 degrees, and we're at 270, that'd be 315 degrees. All these places, all right, all these places on the unit circle create a 45-degree angle. Where? Can everybody see the 45-degree angle right in here? So right now, if you focus right here, this angle right here makes a 45-degree angle. Right here makes a 45-degree angle. Right here is also a 45-degree angle, and right here is also a 45-degree angle. Now, in a unit circle, I want you guys to understand that with this radius, we're going to call it a 2 all the way around. And these sides are radical 2, and this is negative radical 2. This side is positive radical 2. This side is negative radical 2. So when you guys are dealing with the unit circle, all of these points right here, these are all plus or minus radical 2 over 2. So we have 4 different places on the unit circle that could be a plus or a minus radical 2 over 2. So now that we know where we are in the unit circle as far as degrees, you guys need to know how to convert your degrees to radians. So you always take whatever degree that you have, we'll go right here, whatever degree that you have, you need to multiply it by pi over 180 degrees, and that will give you your answer in radians. That will always change it or convert it. So if I do 45 degrees times pi over 180, you are left with pi over 4. If you take 135 degrees and multiply by pi over 180, you are left with 3 pi over 4. If you take 225 degrees and multiply it by pi, not pi over 4, sorry, pi over 180, you are left with 5 pi over 4. And if you take 315 degrees multiplied by pi over 180, you are left with 7 pi over 4. These are all of your answers in radians. Okay? So you're not trying to do the calculator, just do 45, basically divided by 180. 1/4, which is pi over 4. Okay? What was the next one? 135 divided by 180. 225 divided by 180. Now why did I not stick the pi next to it? Because if you do, it's going to make a ridiculous decimal. So what did I just add to every single one of these answers? I just made this a what? Put the pi right there, put the pi right here, put the pi right here. That's how you can convert it. All right, that's kind of what I do if I don't know it outright. So what are your 4 answers? These are all 4 of your answers. These are the values of x. If you want to, here, let's prove it. Here we go. If I say the sine of 45 degrees, what do you get? You get this answer. Well, what is radical 2 divided by 2 equal to? It's equal to that number. Watch what happens when I say the sine of what? 135. What's that equal to? Right there. What if I say the sine of 225? What's that equal to? So what is this decimal equivalent to?
135.
What's negative radical 2 over 2? And last, what's the sine of 315? So what I'm attempting to explain is that this is equal to negative radical 2 over 2. This is equal to negative radical 2 over 2. This is equal to positive radical 2 over 2. And what was our answer equal to? Plus or minus radical 2 over 2. So we have to include all 4 answers, not just one answer, okay, because it meets all the conditions. So what I'd like you guys to do in your journal, the final answer is this. These are all of your answers, okay? Every single one of these is a correct answer. But what can we also, it says if you want all the answers, you have to add what's called, you can add 2 pi n. And what does n represent? From yesterday, what does the n value represent? The number of revolutions, whether it's positive or negative, okay? So these represent all the values of x that are equal to our answer. We're going to go and change our calculator to radian mode real quick. And we're going to hit, I'm going to go to the window real quick. I'm going to go 0. I'm going to do my x maximum at 2 pi. My x scale, I'm going to do at pi divided by 4, at pi over 4. My y minimum, I'm going to do -5. My y maximum, I'm going to do a +5. Now, take Could you, I'm going to hit the window button here just so you guys can see the window button. So what was our original equation? All right. It was 2 sine, right? Sine, ooh, how did we do that? 2 sine of x, I'm going to close parentheses, and I'm going to square it. And then minus 1? Minus 1. Okay. I'm going to hit the second format. The grid lines turned on. Okay, so here's, by the way, here's how I typed in the equation. Notice, I didn't square the whole thing. What's the only thing I squared? I only squared the sine of x squared. Okay. So something you guys need to know, if I say, by the way, that's 2. If I say the sine squared of x, everybody, that's going to be the same as the sine of x, if I put that in parentheses and I square it. These mean the exact same thing. All right, so in the calculator, by the way, the calculator, I can't write it like this in the calculator, but I can write it like this in the calculator. Now, by the way, we're trying to figure out where this is equal to what? Where this is equal to a 0. So, by the way, you see this point right here? And this point right here? And this point right here? And this point right here? Now, what did I say our x scale was? What did I say our x scale was? Pi over 4. So, where was it equal to 0? It was equal to 0 at pi over 4. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. Now what I want you guys to understand, what was our x minimum? Our x minimum was a 0. What was our x maximum? 2 pi. Does this graph just stop between 0 and 2 pi, or does it go forever? It goes forever. So that's why I had to add plus 2 pi in to all of your answers. Because if I took that exact same graph and I said, we're going to change the window, we're going to say, oh, negative 50 pi. We're going to make it go all the way to a positive 50 pi. Then what are you going to see? Okay? You're going to see it continue to do that forever, going all the way stretched out. Okay? So that's another way you can check your answer. You can check, you type the equation in, see where it's equal to the other equation, see where it's equal to 0. All right? So we're going to go ahead and the last problem we're going to do today is problem number 3, and you're going to try to do problem number 4. So we're going to go ahead and look at problem number 3 right here. Go put that in your journal. Okay. Right now, the biggest thing that I see that we need to take care of is this pesky radical. So what do we need to do to get rid of that radical? Go ahead.
Multiply both sides by 2. Or square both sides.
Square, yeah, square both sides. What I want you to do first, I want you to take this side right here, and I want you to take this side right here. I want you to square this side, and I want you to square this side. When you square it, you have left a cosine of x. Now, what does every high school graduate should know how to do before they graduate?
Would you like
No, not would you like fries with that. No, we don't want that. All right? We want you guys to be able to FOIL things out. So what I want you to do right now, on your own, come up with an answer you think is a legitimate answer by using the FOIL. Go ahead and FOIL that out. All right, you lollygaggers, here we go. Let's focus in. We have a 2 cosine of x times 2 cosine of x. What is that going to give us?
4 cosine of x.
4 cosine squared of x. We have 4 cosine squared of x. Now we're going to do 2 cosine of x times a negative 1. That's going to give us a?
Minus 2 cosine of x.
There we go. Minus 2 cosine of x. Now I'm switching colors here. I've got a negative 1 times a 2 cosine of x. That gives us a?
Negative cosine of x.
There we go.
Same plus.
And then we have a negative 1 times a negative 1, which makes a positive 1. So what is our final result when we FOIL that out? We should have a 4 cosine squared of x, right there, 4 cosine squared of x, minus 2, not sorry, not minus 2, minus 4 cosine of x plus a 1. And what's that equal to, everybody? That's equal to another cosine of x. So when you FOIL all of this out, this is your result. At this point, what I'd like to do is I'd like to set the equation equal to 0. Set it equal to 0. So we're going to take away a cosine of x over here, and we're going to take away a cosine x over here. So now I have what? I have 0. This right here, that basically is 0. We still have 4 cosine squared of x minus. How many negative cosines of x do we have? 5. 5. So 5 cosine of x plus 1. So here's what I want you guys to do. We're going to test your factoring ability. Let's pretend right now we're going to replace this right here. I want you to pretend, what if I said, what's 4x squared minus 5x plus 1? See if you guys can just factor that quadratic equation. Okay? All right? So another way you'll see it in textbooks, you'll see it like this. You'll see, okay, make the letter u equal to the cosine of x. So they would say factor 4u squared minus 5u plus 1. So you don't get the letter x confused with what you're factoring. So right now, go ahead and see if you guys can factor this. Put the 4 and the u here, put the u here, and then you're going to figure out what you need to do to get the correct factors where these multiply together to equal this product. See if you can do that. What are the only two numbers that can multiply together to equal a 1? 1 and 1, or what's another way you can multiply two numbers together to equal a positive 1? Negative 1 and negative 1. So look what happens when I put a minus 1 here and a minus 1 here. What's the product of 4u times a negative 1? Negative 4u. What's the product of negative 1 times u? A negative u. What do those add up together to equal? A negative 5u. So these are the correct factors. Now what we're going to do, just to the right, over here, we're going to replace it with the cosine of x. So instead of 4u, what am I going to write over here? I'm going to write 4 cosine of x minus 1. And instead of u, what am I going to replace u with? The cosine of x. Put the cosine of x minus 1. And what are we setting all of this equal to? We're setting it equal to a 0. So everybody, these are the factors. This times this. If we were to work through the whole FOIL method, once again, what would we get back to? We get back to this equation right here. This expression. Now, what are we trying to figure out? We're trying to figure out where are these equal to what? Where are these equal to 0? So we're going to have two answers. The first answer is this. You're setting 4 cosine of x minus 1 equal to a 0. The other equation right here, you're setting the cosine of x minus 1 equals 0. So you're setting this equal to 0, and we're setting this equal to 0. Why are we setting them equal to 0? Because as soon as you make 1 equal to 0, 0 times anything is 0. So, how would I solve this equation? Add 1. We have 4 cosine of x equals 1. Divide by what? Divide by 4. Divide by 4. And what is the cosine of x equal to? It's equal to a 1/4. Okay. Over here, cosine of x equals 1. If I add a 1 to this side, and I add a 1 to this side. So we have two possible answers. The cosine of x could equal a 1, or the cosine of x could equal a 1/4. So what do we have to apply to both sides to find out what x is? We have to apply the inverse button. What I want you guys to do right now, go ahead, in degree mode, go ahead. Let's find the inverse of 1/4. And over here, find me the inverse of 1. Tell me what you get. Okay. Second, cosine 1 divided by 4. Oh, wait, gotta change the mode. Back to degree mode. About a 75-degree angle, 76-degree angle. And what's the cosine of 1? What's the cosine of 1 always equal to? By the way, look at your answer for problem number 1. What's the cosine of 1?
0.
0. Okay. So, this right here was approximately equal to what? 75.5 degrees. And this is right here, this one was equal to 0 degrees. What would that be in radians? What would I have to do to that 75?
You put 75 times pi over 180.
Pi over 180. And by the way, when you do that random, that's what you're gonna get. When you take this right here, this answer, and you multiply it by pi divided by 180, look what you get. This is your answer in radians. Now, you guys have to be able to find a way to be able to check it. Okay, we have two answers. We have 0 and we have this answer in radians. What's our approximate value in radians? Our approximate value is this right here in radians. So what I'd like you to do right now, go to y equals, figure this out. Raymond, what's the first equation that we have on the left-hand side? You have the square root of cosine, right? Square root of cosine. Square root of the cosine of x. Alright, that's what we have. What do we have on the right hand side?
2 cosine of x minus 1.
2 cosine of x minus 1. I'm changing my mode right now, changing my mode to radian mode. I'm going to change my window. I'm going to go back to 0 and 2 pi. Keeping my x scale at pi over 4. And I'm going to hit graph. I'm going to be graphing both of these and see where they intersect. Where is this graph equal to this graph? So right now, where are the only points where this graph is equal? Right here. And where is it once again equal to the graph? Right there. Okay? Which means it looked like this was going to go down, but it stops where? Why does it stop right here in blue? Because we're dealing with the what? The square root of the cosine of x, so it stops right there. So you actually, there's an answer that does not work. Where am I here? I'm at 0. Where am I here? I'm at 2 pi, which basically is 0 plus what? 0 plus 2 pi. So of the two answers, which is the only answer that seems to work?
Cosine of x equals 1.
This is the only answer that works. The other answer, right here, this answer does not work. Let me prove it to you real quick. That didn't make sense why those two graphs did not intersect at the other place. Right now, I'm going to say the cosine of square root of the cosine of, where is it? Right there. That's what it's equal to. Okay? Now what was the other equation? 2 cosine of x. So let's scroll back up, grab that answer that I got in radians. There's the answer I got in radians, which is approximately equal to that 75.5. And then what do we have to do? We have to take away a 1. So look what happens. This is equal to what? Basically 0.50. What's this equal to? Negative 0.5. So what happens is whenever you have to square a radical, sometimes you're going to get what's called an extraneous solution. So we had an extraneous solution in this particular case. Which one was the extraneous solution? This guy right here. The only answer for this answer on problem number 3 is this. Your answer is 0 plus 2 pi n. That's what x is always equal to. It would those graphs would continue to intersect every single time it hit 2 pi. And only then.